people spend ludicrous amounts of money on mountain bikes. If you're going to spend so much money, you probably want to make sure that the suspension is actually doing something, and that the floaty cushion you feel isn't because you're riding on smooth terrain like some kind of whim. To find out, one PocketLab was strapped to an unsprung portion of a bike, while another was strapped to a sprung portion of the bike. This way, we could see the difference in peak accelerations pre- and post-suspension. In this test, the mountain bike was ridden off a curb. The unsprung data stream comes from a PocketLabs accelerometer that is mounted to the seat stay of the mountain bike, which is directly connected to the rear wheel. The sprung data stream comes from another PocketLabs accelerometer that is mounted to the top tube of the mountain bike. A linkage-driven air shock connects the seat stay to the frame, so there should be a significant difference in accelerations if the suspension is working.
Whee! From the data, it is possible to see the difference between the front and rear wheel impacts. The frame-mounted PocketLab is affected approximately equally by front and rear impacts, but the seat stay-mounted PocketLab is much more dramatically accelerated by the rear wheel impact, suggesting that my suspension is not just an inert hunk of metal. It turns out that while both PocketLabs were set to measure at 50 Hz, there was a small difference in the length of each sampling period. This difference grew after taking a large number of samples and had to be accounted for. To sync up both PocketLabs, we lightly hit the cranks with the mallet before and after the test. We could then match up the acceleration peaks of the mallet taps and normalize and adjust the time measurements of the PocketLab. This system can be used to gauge how active a bike's suspension is, and may even be helpful for tuning suspensions. But most importantly, it's very helpful for justifying mind-bogglingly expensive purchases and lifelong debt.